In this video, we are going to be solving a problem on Gauss law. Okay, now here is the problem on the board. Consider two large parallel plates of area 1 millimeter separated of area 1 meter squared, rather separated by 1 millimeter. If the plates have equal but opposite charges of magnitude Q equals 10 to the power of minus 3 coulomb, find the force between the plates. Okay, that's what the question said. Now, to solve a problem like this, you should have known what Gauss law talks about, or the formulas that comes with it here. Now, we've made a video on Gauss law initially. You can check our playlist. It should be the first video there. Okay, introduction to Gauss law. So you might want to watch that video and gain more understanding on Gauss law before attempting a problem like this. So for a problem like this, I would like us to draw what we're having. The question talked about two parallel plates. Okay, now we said they are not just two parallel plates situated at a distance of 1 millimeter apart, but rather they are having an area of 1 meter squared each, and then the plates are having opposite charges, okay, but the same magnitude. So let's say this one is for the positive charges, okay, this one is going to be for negative charges, okay, and they're asking us to find the force between the plates. Now we do know that the force is going to be, or the flux rather, they are going to move from positive to negative. So let's say we're going to have something like this, okay, something like this. Now if you notice, this is an open surface. In our previous video we talked about closed surfaces, okay. If it is not a sphere, most times we bring in a cylinder that will help us enclose the surface and then calculate the force, okay, or the electric field using what now? The Gaussian law. Now if you've forgotten what Gaussian law is, it simply states that the net flux through a surface, okay, is equal to the enclosed charge divided by the permittivity of free space, and it's also equal to the integral of electric field times area. Okay, now for an open surface like this, we need to bring in a Gaussian surface. Okay, in this case we're going to bring in a cylinder. Okay, we've done something like this in our previous video, so you might want to watch that one if you do not understand this. Okay, bring in an imaginary cylinder. Okay, we'll assume that this cylinder is inside of this sphere. Okay, now we also derived a formula for calculating something like this when we talked about an infinite long line of charge. Okay, so if I were to do that again, we're going to have something like the flux is going to equal, remember we're having two sides of the area, so I'm going to multiply by 2. The proof is on the other video, so even if you don't understand the proof here, there is no problem with that. Okay, so when we do that, so we're going to get 2EA. Take note, we're not just integrating this to get this. That is not where the 2 comes from. The 2 comes from the fact that we're having two sides, okay, two sides, and it's something we've done before. So we're going to have flux equals 2EA, and this is also equal to charge over permittivity of free space. So from here, E is equal to Q divided by 2A E naught. Okay, now we have to calculate the force. Now to calculate the force, remember that F is equal to what now? F is equal to E times Q. Yeah, so if I plug this in, I'm going to get F equals Q squared divided by 2A permittivity of free space. Okay, now if we continue with that, so we're going to get a value of F. We're given Q as 10 to the power of minus 3, okay, all squared, divided by 2 times the area in this case is 1, times permittivity of free space, a constant, 8.85 times 10 to the power of minus 12. Okay, now we'll punch this on our calculator. When we do that on our calculator, we're going to get a value of 10 to the power of minus 6 divided by 2 times 8.85 times 10 power of minus 12. Okay, so you're going to get a value of 5.65 times 10 to the power of 4 in force is newtons. Okay, so this is the value of our force for this particular problem. So you see, it's quite easy. What you need to take note of is the formula that is being made use of here. Okay, nothing you really need to cram. All you have to do is watch the previous video, and definitely you're going to get more understanding on what I just did here. Okay, so here is how a problem like this is being solved. Do well to like, share, and subscribe to your friends. Click on the notification bell so that when the next video is being uploaded, you'll be one of the first 2 persons that will get notified about it, okay? And then you get to learn. See you in the next video. Bye.